Okay, we are on 6.01 for A2 today, and trying out another new method, so the audio is a little bit shaky here, but hopefully everybody can hear okay. And we're going to be doing multiplying and dividing rational expressions. So expressions means we have no equal sign. It is not an equation, just an expression. All right, so a couple things to remember. When you are dividing, remember to keep, change, flip. KCF, keep, change, flip. And the other thing is your opposites are going to divide out and equal -1. So for example, if you had x minus 3 over 3 minus x, so 3 minus x. So if you have these two binomials, then these would cancel out to give you a -1. So you would cancel those out, and I always like to put the -1 on the top. And the reason that works is if you take x minus 3 and you factored out a -1, which means I divide each of these by -1, I'd be left with -x plus 3. Using commutative property, I could rewrite that as 3 minus x. So x minus 3 and 3 minus x are the same, just different order. Subtraction is not commutative, so you have to make sure you take out that -1, and then they are the same. So these are some really important things and common mistakes that students forget to do. So number 1, simplify. X squared minus 9 over 2x squared plus 2x minus 12 times 8 minus 4x over 3x minus 9. Okay, so to do this one, first of all, you want to know what type of problem it is. So since we have two sets of fractions and they are being multiplied together, then we know this is multiplication or division. I want you to be thinking factor, cancel. So anytime it's multiplication or division is an expression, think factor, cancel, which means factor each numerator, each denominator separately, and then see what you cancel out. One of the big things here is you cannot cancel things from the top to the bottom if it's next to addition or subtraction. So here, if you have an x squared and a 2x squared, those cannot cancel out because this x squared is attached with subtraction and this x squared is attached with addition. So you're not allowed to cancel things out if they are next to addition or subtraction. Again, you cannot cancel things out if they are next to addition or subtraction. We can only cancel them out if it's multiplication or division. So we are going to factor each numerator, each denominator. So first, I'm looking at just this numerator right here. All right, so we're going to factor that. That one is a difference of 2 squares as our dots. So we factor that as x minus 3, x plus 3. All right, now I go to my denominator here. Highlight that in this teal color. 2x squared plus 2x minus 12. So to factor that, it has a 2 in front of the x squared, which means I need to use p's and c's. So off to the side here, I'm going to just show my work. So I'm going to take 2x squared plus 2x minus 12, and I'm going to factor that using p's and c's. So my p is negative 24. Product of my first and last term. C is positive 2. I need two numbers that multiply to negative 24 and combine to 2. And actually, I kind of dove right in here to P's and C's, but even easier, you could have just factored out your 2. So let's do it that way actually instead. So here I see a GCF of 2, so I'm going to divide everything out by 2. So I have to make sure I write that 2 on the outside. So now I have x squared plus x minus 6, and that'll actually be quite a lot faster than using P's and C's. So now I can go straight to guess and check. P's and C's would work. You would just have to take out the 2 at the end if you hadn't already. So now I have x and x. I need to multiply to negative 6 and add to positive 1. So that's going to give me positive 3 and negative 2. So now I'm going to bring that back over to my denominator. So 2 on the outside, x plus 3, x minus 2, times, here I have 8 minus 4x. So I'm going to always look for my GCF, which I wasn't very good about doing before, but you need to make sure you do that. So take out your 4 from both of those, which will leave us with 8 divided by 4 will give us 2 minus x. In the denominator here, I can factor out a 3 from both of them. Make sure you write the 3 still. So leaving you 3 times the quantity x minus 3. Now that I have every numerator and every denominator factored, here comes the fun part of canceling. So you can only cancel if something's the same, exactly the same from the top to the bottom. If it's addition, it doesn't matter what order it's in because addition is commutative. And if it's subtraction and they're the wrong order, that's when you want to take out a negative 1. So I look up here and I see x minus 3. Do I see any other x minus 3s on the bottom? And it could be either fraction. And I do, so I'm going to cancel that out with that. They divide out to give me a positive 1. Then I have x plus 3. I have an x plus 3 on the top, an x plus 3 on the bottom. Again, divides out to give me positive 1. Do you need to write the 1? No. Can you? Sure. Then I have 2 minus x and an x minus 2. So I have subtraction, same exact terms, but the wrong order. So when that happens, you're going to cancel them out and replace it with a negative 1. Again, I like to put the negative 1 on the top. Make sure you don't put it both places because then that's the same as doing a positive 1. All right, so let's just write what we have left. So in the top, all I have left is a 4 times my negative 1, so negative 4. And in the denominator, I have 2 times 3, which is 6. So now I can reduce that to negative 2/3. Something else that's important to recognize here is you could have also seen the 4 and the 2 here and said, oh, well, I can reduce those as well. 2 goes into itself once and into 4 twice. And then I would be left with negative 2 on the top and 3 on the bottom, which would give you, again, your negative 2/3. So pretty crazy that that whole long complicated expression is actually just equal to negative 2/3. Crazy. I love it. Let's do another one. So simplify again. Okay. Divided by thrown in here. Sorry, the clicking of the pen is super loud for you. All right, so first I look at this and I notice it's all multiplication and division. So when I'm multiplying, dividing fractions, I think factor, cancel. It's an expression, there's no equal sign. So I want to factor each numerator and each denominator and then try to cancel. I also see division here. So whenever I see division, I should be thinking keep, change, flip. And what that means is keep the one directly before the division symbol. So this one, change division to multiplication, and flip the one that comes directly after it. All right, so let's start by you know what, to save some time, I'm gonna do that as I factor and cancel as well. So, or you know what, we'll write it all out so no one gets confused. So first, and as you guys get a little bit more practice with these, you might skip that step and might do more than one step at a time. So all I'm gonna do here is keep this fraction the same, change division to multiplication, and then flip, keep, change, flip. Now flip this last one to be x squared plus 6x plus 8 over x squared plus 2x minus 3. Now it's time to factor and cancel. So go ahead and pause your video and see if you can factor each of these numerators and each denominator on your own. All right, so hopefully you have factored these on your own now, and I'm going to go through them pretty quickly, but one thing I want to remind you is to always look for your GCF first, and then see if you can factor it after that. So the first numerator right here, I'm looking at, I've got 2x squared y minus 2xy. It's only two terms, so I want to make sure that I look for my GCF first. So I'm going to factor out a 2 because I can take a 2 from both of them. I can take an x from both of them and a y. So if I divide each of those by 2xy, that'll leave me with just an x. And this is 2xy, so it doesn't go away. It becomes a 1, because when you divide something by itself, it gives you a 1. If you need to do that off to the side and show your work, if you want to divide each of them by 2xy, and that helps you, go right ahead and then write it out, and then you can see that it cancels out to be just x minus 1. All right, now we'll go to the denominator, the first denominator. So now again, it's only two terms, so I'm going to look for my GCF. My GCF here would be 3x, and you'd get x squared, or rather, actually I can take out an x squared. So I want to take out the largest GCF, so 3x squared, which will leave us with x plus 2, times x squared minus 9 is a difference of two squares, x minus 3, x plus 3. Again, only two terms. I'm going to take out my GCF, which is 4y, leaving me with x plus 4. And then here we've got trinomials, so I'm going to factor those. I need two numbers. There's no GCF here, so I need two numbers that multiply to 8 and combine to 6. So that's going to be positive 4, positive 2. And then in the denominator, I need two numbers that multiply to negative 3 and add to 2. So that'll be x plus 3 and x minus 1. And here comes the fun part. Once we have everything factored, we get to cancel. So now I see in x minus 1 up here in the first fraction and an x minus 1 all the way at the bottom. Again, in order to cancel, one has to be on the top, one has to be on the bottom. It does not matter which fractions they're in, and they have to be exactly the same. If it's subtraction, they can be a different order, but if that is the case, you need to take out a negative 1. All right, now we have x minus 3. I don't see any in the denominator. X plus 3, x plus 4, and x plus 2. Also from here, I might see, okay, I have a 2 on the top here and a 4 in the denominator here. So 2 goes into itself once and into 4 twice. I might notice here I have a y and a y that I can cancel out. And then if you have trouble seeing those pieces afterwards, feel free to rewrite it and see what you have left. So maybe that's all I see at this point. And now I'll write what I have left, which is just x in the numerator and x minus 3. And in the denominators, I have 3x squared, and that's it. So now I'd look at this and say, is there anything I can cancel here? And there is. I have an x and an x squared, and these tend to be the ones that students always forget when they cancel. So make sure you look for these. So it's all multiplication next to them, so we're allowed to reduce. So this x will go and divide into the x in the denominator. Remember, with division, you subtract your exponents or ask yourself, where do I have more x's? in the denominator. How many more? 1 more. Leaving us with now x minus 3 over 3x, and I forgot this 2 before, so this would be, let me put that in blue. So now I can multiply that 3 times 2 together to leave me with 6x. So final answer, x minus 3 over 6x. I think because I've used different colors, I didn't see it. So be careful if you do that. Don't forget that 2 right here. That's where this 2 came from. So 3x squared in the denominator and that 2. And then we can't reduce our x's, and then 3 times 2 gave us 6. And again, you cannot cancel this x and this x because this x is attached to that 3 with subtraction. So if it's next to addition or subtraction, you cannot cancel it. All right, let's try another one, x squared y over 6. This one's a little bit shorter, but sometimes when it's different like this, you guys get a little bit more confused, so I wanted to show you one like this for you just to see the difference. All right, so looking at this, I see multiplication and division. I do not see any equal signs, so I know it's an expression, so I think factor cancel. I don't really see any binomials here. So first I'm going to focus on getting rid of this division. So I'm going to do keep, change, flip. So keep what comes directly before it, change this to multiplication, and then flip. And then you just keep your x over y. Pause the video and see if you can cancel it from here. All right, so hopefully you started to look for things that you could cancel from the top to the bottom. So a 6 goes into itself once and into 12 twice. I see I have a y on the top and a y in the denominator. I could cancel this x squared and this x, leaving me with 1x in the numerator, or maybe you cancel this x and this x. And then let's look what we have left. So we've got x squared in the numerator and a 2 right here, so that's 2x squared. And in the denominator, I have a 1 and a y. Oh, you know what? I lost my y to the third when I rewrote that. So that means, I'm just going to fix this here. So instead of canceling with that y, actually I think it would be easier to cancel with that y. Otherwise you would have had y to the second left. Right there. And then you would have had the additional y over here. So a little bit easier that way. So in the denominator now, I have y to the third. And I can't cancel anything out from there. Okay. Find the product of 4x squared plus 8x minus 5 over 4x to the third minus x, and 4x squared plus 8x over 2x squared plus x minus 10, expressed in simplest form. So hopefully you're thinking product means multiplication. So go ahead and try this one on your own, finding the product of those two. Think it's an expression, there's no equal sign. Multiplication of fractions, think factor, cancel. All right, so first of all, you should have written it out as multiplication. We do not need to do any keep, change, flip because it's multiplication. So now I want to do my factor cancel. So I would have gone off to the side here to show my work. And first I would factor 4x squared plus 8x minus 5. There's no GCF here, so you would go ahead and do your P's and C's. So this time I'll walk you through it if you need a little refresher. 4 times negative 5 is negative 20. That's the first and last term. C is positive 8. And we need two numbers that multiply to negative 20 and add to 8. You can go to your y equals if you want. Type in y1 equals negative 20 divided by x and look for two numbers that add to 8 from there, which should be 10 and negative 2. So now I write this out as 4x squared blank x. So as 4 terms, I split the middle into 2 blanks. And I'm going to split 8 into 10 and negative 2. So do positive 10, negative 2. Group up your first 2 terms and your last 2. Factor out your GCF here of 2x, leaving you with x plus 5. Here the first number in the parentheses is negative, so I should take out a negative 1, leaving me with 2x plus 5. And over here I've lost my 2 there. 4x squared divided by 2x would give you 2x. And then now 2x plus 5, these two are the same. Rewrite that one time. Times 2x minus 1. Okay, so now I can go back up here and replace that first numerator with 2x plus 5 times 2x minus 1. Okay, if you weren't able to start it, so now that I've given you a little start, go ahead and finish the rest. So factor each numerator and each denominator. So these 3 all need to be factored. All right, so here you should have taken out your GCF, leaving you with 4x squared minus 1. And looking at that now, I can factor 4x squared minus 1 even further too, because that's also a difference of 2 squares. So I took out a GCF, and now I have a difference of 2 squares. So that would be 2x minus 1 times 2x plus 1. So I'm just going to cross that off. Here I have a GCF of 4x. Which would leave me with x plus 2. And then again, I would need to use, I look for my GCF on this last denominator. There isn't one, so I have a 2 in the front of the x squared, which means I want to use p's and c's. So off to the side here, I would do my p's and c's. And on your papers, you should have your p's and c's written out. So if you haven't done it, go ahead, pause the video. I need to see this in your notes that you've done your p's and c's. And then bring it back into this fraction. Once you've done that, you're going to go ahead and cancel out your like terms. So I'd like you guys to finish this one completely on your own now and check back for the final answer. All right, so once you factor that and cancel, your final answer should be 4 times the quantity x plus 2, 2x plus 1, x minus 2. So on your papers, I should see that you have finished this problem. So finish factoring that last denominator and canceled out any like terms from the numerator to the denominator. All right, so that was 4. We'll do one more. Over 3x to the third plus 6x divided by 9 minus x squared over 10x squared plus 30x. So pause and see how far you can get on this one. I know this first numerator is a little tricky, so you need to stay to go over that. Then go ahead and pause it after that. All right, so I'm going to do some work off to the side here. So I'm going to factor x to the third minus 3x squared plus 2x minus 6. So this one's different because it's 4 terms and there's no like terms there. So what I want to do is I'm going to factor by grouping. So I'm going to group my first 2, group my last 2, and then it's like the end of P's and C's. So if you're good from there, pause the video, finish this whole thing on your own now. If not, factor out your GCF of x squared, leaving you with x minus 3. Here we take out a positive 2 with x minus 3, and then you can regroup. So you get x minus 3 times the quantity x squared plus 2. Okay, from there, pause the video, put that in. Make sure you pay attention to your division, so keep, change, flip. Factor everything, cancel it out, and then find your final answer. All right, so on your papers, you should have put this in. In the denominator, I factor out a 3x. And here, I want to keep change flip. So you should have keep the first one, change to multiplication, factor out a 10x. And here, when you factor this, it should be 3 minus x times 3 plus x, not x minus 3x plus 3. If you have that, it's wrong. Please fix it. Now you have it all factored. Now go ahead and cancel. The only one that I wanted to draw attention to here was your x minus 3 and your 3 minus x. Since those are the same numbers but different order, you should have made sure to take out a -1 there. And then I'll let you do the rest on your own. I will take a note here, x plus 3 and 3 plus x. Since it's addition, those can cancel out. There's no -1 that comes from them because x plus 3 is the same as 3 plus x. 2 plus 3 is the same as 3 plus 2. Addition follows the commutative property. So once you cancel everything out, you should have left -10 over 3. And that is it for today. So if you have any questions, make sure you see me. These are a lot of fun, so I hope you enjoy them, just like a puzzle. And pi out.